Hi folks, Harry Frank from Red Giant here. Thanks for joining me for week 2 of AFX 217. I'm going to switch around the schedule just a little bit, and we're going to be focusing on this error ID rather than the space ID that I was talking about last week. We're still going to dive into trapcode form and trapcode particular, but a big chunk of this other lesson, or this ID here, uses a new version of Null Light Factory. And even as interesting as it would be to give you a preview of it, which I guess I can do right now, the interface isn't finalized, and you can't get a version of it anyway, so it's not going to do a whole lot for you in terms of an educational value. It would just be neat to show it, and I don't think that's a good value for your time and money. So let's come back to the Space ID once I can actually show you Null Light Factory 3.0 and all the cool new features in there. And instead, let's jump on to the error ID. So I mentioned we're designing a broadcast package, or at least designing components of a broadcast package that focus on or use as a motif the four essential elements, four basic elements: earth, wind, fire, and water. So this week we're going to do an error ID, and we'll be using error is invisible, so we'll show things that interact with air, like clouds and birds. And this is a good lesson to go through Trapcode Particular's motion paths, and we'll also dive into Trapcode Form and Particular, and sort of, when you want to use one or the other. And that's about it. So let's get started, because there's a lot of stuff here. Some of these photographic elements, all of these photographic elements will be included, and just a great tip for you, as I was looking for these, I found a lot of these listed through Creative Commons, tying all back to the U.S. Fish and Wildlife Service digital library. There's a lot of not so useful stuff, but there's a lot of great public domain images of mountains, clouds, fish, birds, that kind of thing. Later on, when we get into the underwater IDs, I found some great photos of fish that we can use for our underwater sequences. So anyway, you'll have all these things to work with. Oh, and another thing, as you can see, we're using some video footage of birds as our particle type. And we actually need to get in and prep these to be used as particle elements for Trapcode Particular. And what we need to do is key these out. Actually, I can see I've got a little keying cleanup to do. But we also need to stabilize these, because this is basically a bird flying across the screen, and there's quite a bit of stabilization that's needed. And a perfect way to do that is using Mocha Pro. So let's get started. Let's create my comp here for our error ID. I always call my lesson version the lesson version, because it always turns out different. So I always distribute both the final version that looks nice and polished, and then the one that I do on the fly that never looks quite as good as the polished version. So this will be the lesson version, and I'll send both of these along. So rather than jumping into the photographic elements, let's actually work on our particle elements first. So I mentioned we'll be using Trapcode Form, and also talking about Trapcode Particular and when you'd want to use one or the other. So I'm actually going to make two layers. I'll call one Particular Clouds. I'm very anal about my capitalization when I name things. Let's create a camera. I know there's nothing in there that's going to be affected by cameras just yet. And on the Form layer, let's apply Trapcode Form. And Particular layer, we'll apply Trapcode Particular. Okay, let's turn that, just keep that off. So I could use Trapcode Particular for the clouds. And if we just do a quick mock-up of this, we'll start to see what the challenges are as they arise. So by default, Trapcode Particular emits particles from a single point, and they move away from the point of emission, and we find those settings in the emitter. The emitter section is always where the particles are born and how fast they are moving and what direction they're moving at the point of emission. So basically everything to do with how the particles are actually created and what they do at the moment of their creation. So we twirl the emitter section down. well, obviously particles per second is how many particles per second are being emitted at this moment in time. X, Y, and Z locations are pretty straightforward, but what we're concerned with right now is the emitter type. By default, we have a single point, basically an infinitely small point or single pixel point in space where all the particles are being emitted. Because it's a single point, there's only one direction for them to go, which is away from that single point. By default, we have a velocity of 100, so they need to move. They will move randomly in all directions. And that's what this direction is right here. They're uniformly moving in all directions. So if I set this to something like directional, you'll see, well, it's sort of sneezing out in one direction here. Let's reset my camera. And I can rotate this around like that. But what we're more interested in is, I think I already said this, the emitter type. So rather than a single point, we want a box. And I'm going to zero out the velocity because it's hard to visualize the shape of this box if they're all moving from the point of creation. Sort of like kitten wrangling, you know, like trying to count your kittens and they're all moving around. So let's tell them to all stay put by zeroing out the velocity. And now we can see that box area. It looks pretty small. In fact, it is 50 by 50 by 50 in X, Y, and Z. You can see it's sort of a little cube. So let's, oops, I keep moving my camera around. Let's reset my camera again and then go into my emitter size. Oh, I also rotated this, that's why. Zero out that rotation. Now we can see that this is indeed the x-axis. So if I want clouds, I can simply stretch out this emitter area in x and z. So z moves them towards the camera. I'll move the position down so I have this nice little field of particles. And if I swap these out for some sort of cloud kind of image, we can get something that, well, looks fairly close to clouds. Now, if we want to do this procedurally, in other words, do it entirely within the interface of Particular without involving any images, we can try to do that, and it'll come pretty close. If I go into the particle section, this deals with everything that has to do with the look of the particle. So the type of particle, the size, color, the randomness of all those components that go into it. As well as the lifespan. And this is one of the huge differences between Trapcode Particular and Form, is that, as I mentioned last week, particles in particular, they're born, they do stuff, and then they die. And that cycle is defined in the life right here. So if we want clouds, we probably want a fairly high lifespan, at least 10 seconds, so they all pop on. So the longer the lifespan, the more particles we see on the screen at any given time, because we have more lifespan overlapping. Now you'll notice from the very first frame 0, we don't see any particles. And this is how Particular behaves. It starts generating particles from the very first frame. But if we'd like to see more particles from frame 0, we can go into Emission Extras and crank up the pre-run. And one of the things that I was always a little confused about with pre-run, before I dived, before I basically became my job to understand how these plugins work in detail, pre-run is a bit tricky. It's not actually expressed in any sort of seconds or percentage or anything like that. And this really depends. It depends on the lifespan of the particle, really. This is going to run a percentage of the lifespan of the particle. It's going to run the simulation up to 100% before frame 0. So essentially any complete life cycles that it would need to get pre-run, basically it would pre-run the life cycle of all the particles before frame 0 up to 100%. So it's basically, I guess you can think of it as a percentage of the lifespan of the particle. So it's not in seconds because it depends on the lifespan. It's not in I guess we could really express it in percentage. So 100% means that we will have run the simulation of particles 100% of the lifespan of the particles before frame 0. Basically, if you want to see a lot of particles from frame 0, you crank pre-run up to 100. That way you don't need any technical explanation. Just crank it up. You don't have to have it all the way up if you want just a little bit of particles from frame 0. I'm going to set it to 100 so we have a consistent amount of particles. You can also see that they're sort of turning on and off, which is their default behavior. So let's go back into the particle section here. And we have two options of opacity or size to eliminate that popping nature. We have two maps that control their behavior over life. So we have an opacity over life and size over life. For clouds, I would suggest using opacity over life so we can control their opacity. We see have a value up and down here, so it's 0 opacity down here at the bottom and 100% opacity at the top. And we have a lifespan, so from the birth to the death of the particle. We have some convenient presets in here that allow us to just quickly click on it and have it fade up and then fade down over the lifespan. Now, one thing to note that this amount of time here that it fades up and fades down is going to depend on your lifespan. So this fade is going to be a lot slower at a lifespan of 10. So I've found for longer lifespans, you actually might want to draw this a little more narrow like that and click the smooth button to smooth that out. So you don't have these long fade outs going. Now from here I can go into my particle type, set it to cloudlet, crank up the size and the size random. This is kind of intersecting with the camera a little bit, so let's move it down. Let's move the change the particle opacity, because that's much more realistic in terms of cloud behavior. And there we go. So fairly realistic looking clouds. But notice that problem that we have. We have these clouds sort of coming and going. It's a particle generator, and no matter what we do, they're still going to have this birth and death cycle. So this isn't always necessarily going to be the best way. Now, one way this kind of works out for you if you want sort of a wind blowing these in a certain direction. So if I crank up the wind in the physics section, or physics, air, wind along the x-axis, I think that birth and death cycle becomes a lot less noticeable. But we kind of have a static cloud field, at least for this design, a static cloud field for this. So I think an alternative is in need here. So let's, instead of using particular, which actually does a pretty darn good job, actually, but I want a static cloud field, and I don't want those particles constantly being born. And actually, before I jump into form, let me see how this actually looks with the cloud particle, which is right here. This should also be included in your footage. There it is, cloud, little cloud sprite. So this is just an image of I pulled together from some clouds, pieced them all together. Notice it is on black. So if I'd like to remove that, I can just simply use null unmult. If you don't have null unmult, which is hard to say, null unmult, simply go to Red Giant's free product section. So redgiantsoftware.com/product/free, and you can see all the free stuff that we've got here. The null 3D flare, null unmult, colorista free, LUT buddy, and quick looks free. These are all free. But right there, null unmult, you basically turn black into alpha channels. And then we'll use turbulence. So under distort, turbulent displace. Let's bring the size down. Basically, this is like a fractal noise that's being used to displace the image. And the reason I say that it's sort of like fractal noise is we have things like complexity, how complex the fractal field is, how the field evolves over time, which is actually going to be something that we need. I'm going to set a keyframe right here at the beginning, and you know what, we need this to be a pre-comp, so actually let me pre-compose this, call this Cloud Sprite 2 because this is the second one I've made, and we'll move all the attributes in, and I'm going to make this 3 seconds long, so let's just trim that up before I get too far. So I've set a keyframe for my evolution, and here at the end, one frame beyond the end of the comp, so at 3, not at, I'm working at 24 frames per second, so at 224, I guess. Well, 223 is the last frame of the comp, and then one frame beyond that is 3. So I'm going to set, oops, not 1 degree, 1 revolution. There we go. Oh, and let's trim this down. I think this is like about 300 by 300 or so. There we go. Now you'd think this is going to seamlessly loop, but it's actually not. As you can see right there, there's a little hiccup. And that is because, just like fractal noise, we have to tell it to cycle. So if I click on cycle evolution, it is going to repeat the fractal noise pattern every cycle, or every 2 cycles if we set this to 2. But I want 1 full cycle. So there we go. Now we've got a nice floating, wispy cloud. And let's go in here to, so let's set that as an element in my comp. If I go into particular, I can set this from, or I can change this from cloudlet to a sprite. A sprite is a custom image that we load in as a particle. Let's go to texture, go to cloud sprite 2, or cloud sprite, or whatever you want to you call yours. And it looks amazingly unimpressive. So we have to do a number of things. We have to randomize these. So rather than sample all of them at the current time, which is actually going to be a problem because we've made ours 3 seconds long, and the ID that I'm making right now is 6 seconds long. So we can't sample the current time because the current time stops at one point. So let's go to one of our time sampling options here. We can tell it to sample 1 random frame, which is one way you can do it, but we can also just do a random sampling of all these clouds. We might need more clouds in here just to fill this in. And okay. Now it's getting there. Another thing we want to do is go into rotation and set a certain amount of random rotation because these are all angled the exact same way. Let's bump up the particle size right here because I really want these kind of big and wispy, and a fair amount of size randomness. There we go. Actually, now that I brought that size up, I think I can bring the particle size or particle count back down. So let's leave that at, let's say, exactly 200, and let's bring the size down just to the point where we start seeing a little bit of detail. Okay. So I mentioned we were actually going to do this with form. So this is getting close with particular, and I certainly wanted to show you how to do this with particular. But as I mentioned, it introduces some challenges that we have to kind of work around, like the lifespan and the turning things on and off. So let's do this with form. Form is is perfect for this. So by default, we have our grid of 3. I just want 1 grid, and I'm going to take this grid and rotate it. Now remember that we're doing that because this is going to rotate all of our axes 90 degrees. So when I think of things in Z, this is actually up and down right now. So I've got a grid of particles in X and Y, and if I take this whole grid and rotate this in X, -90, let's move this down. Let's also scale this out, the size in X and Y. So that's still the Y-axis. So if I change my size Y, it's moving in our visible Z-axis. And that's tripped me up a number of times, so don't make the same mistake. Remember that that's still Y. So I could do the same thing with a cloudlet, but I'm going to use that custom cloud sprite that we made. So let's use a sprite. And if you're wondering what the difference is between a sprite and a textured poly, this is one of the new things in Particular, in the newer version, Particular 2, where we've got 2-dimensional sprites. These are always facing the camera, but texture polygons are 3-dimensional sprites in 2 dimensions, basically 2-dimensional images in 3 D. So textured polygons are free to rotate in whatever angle you'd like them. But we're using flat cloud images, so we certainly don't want to see them rotated on their side. So I'm just going to use a sprite. Let's go into the texture section and texture that sprite. And again, current time, so we have a lot fewer options here because we can sample the current time, or we can sort of split them or randomize them in a number of ways. So I'm going to use random loop, turn up that size. In fact, I think we can use a much lower particle count. In fact, just a note here, if you're working with Forum and you find that it is running slow, the bottleneck is always going to be, well, I shouldn't say always. I mean, sprites, sampling external layers, especially large layers, is going to slow things down. But beyond that, the number one bottleneck in your speed is the number of particles. So especially if you are running a high count and don't actually have a visible, have particles that are being calculated but are invisible. And generally, you can see that particle count in your info tile. In fact, I'm wasting processor speed by having 625 calculated particles, but only 314 that are actually visible because I've got a number that are behind the camera. Probably is the size in Y. So let me scale that down and move the center Z outward or away from the camera. I want to try to get that as efficient as possible. Now we're doing a little bit of a camera move, so it's okay to have a few particles off screen in the other direction, but I think I had a very inefficient count there before. I'm better with that. That's getting there. Now we're always going to have some that are off screen a little bit because, well, this is a square, and I don't want to see the corners that well defined off in the distance. So I generally scale this out so these corners on either side of this box are closer to the edge. Okay, still looking amazingly unimpressive as a field of clouds, even though we've sampled these very randomly. So the turbulent displace is all random, but the angle is still the same. So just like particular, we can go into the rotation and set this to have a random rotation. I'll just set this to 180, so they're all fairly random. And let's turn up the size. Looks like I need more along the x-axis. Set this to 35 and 25. And let's set the size to about 50. And I'm going to bring the opacity down. You can also set this to normal or add. I don't think it's going to make much difference right now. But I'm also going to go into size random and randomize the each particle size, which, by the way, is a pretty accurate way of how cloud shapes would be in nature. You have large variations of very small shapes, very little shapes, medium shapes, and everything in between. And that's one of the main ideas that sort of creates fractal noise or Perlin noise. So to closely emulate that, we can really just go up and crank up that size random to emulate our clouds. I might do a little opacity random as well. There, and so now we don't have any particles popping on or off or anything like that. What we do lose is the ability to have that wind blowing them in a certain direction, because wind, as I mentioned in the last lesson, wind implies some sort of finite lifespan because it's going to blow off screen, and by the time it blows off screen, we're not worried about it anymore. Foreign particles are basically always on the screen, or generally on the screen most of the time. So, depending on how you want to do this, you have two different options. I think I like the look of my clouds that I had before. I guess it's pretty close. Once we start adding other elements in here, so let's pull in just this little mountain that I've got right here. Doesn't that look awesome? It needs a little color correction and additional stuff in there to actually make it not look terrible. But let me put this behind the clouds and show you how quick maps can actually be very useful in cases like this. So I've got all these clouds off in the distance, and I'd like to sort of fade them off. And I could do this in visibility and go in and estimate my far vantage point, which is one way to do it. I think an easier way is to just go into our quick maps and set a map to derive opacity. So I'm going to set this map to derive opacity, and we're going to map it over which axis? I know it looks like Z, but it's actually Y because we're up and down in that rotated axis. Let's draw out a map like that. Oops, and I need to flip it the other way, so click on the flip button. And so this is closer to the camera right here, or I'm sorry, this is further away from the camera, and this is closer to the camera as well. And maybe I want a little bit like that. Let's smooth that out. Now, also over here, because the clouds are in front of the mountain, I want to fade these out just a little bit. So I can actually have two different maps driving opacity in two different axes, which is kind of cool. So over on the x-axis, I can simply do this, and oops. Let's just kind of draw that out so it fades out over on that side. Now we're going to have other clouds over here in the distance, so even though I'm fading them over on this whole side here, really I just want to sort of feather them as they get close to that mountain, and then this area back here will kind of be filled in with additional clouds. But what this does is give us some volume in our scene as our camera moves around. You know, flat images are great for, you know, giving the overall look, photorealism look, but they lack the depth that you're going to get in having a nice particle generator that has 3D parallax as the camera moves around. So that's way too much detail on particle clouds, but it's kind of a nice overview of particular and form in how you would want to use both of them. Now, that said, this is a 200 level class, so this isn't all about introductions. So now that we've got some intros, let's actually dive in and start doing some more complicated stuff. And I want to do that, the flocking birds. So let's actually pull up the source material for that, which you will have. And I'll also include the finished stabilized version of this, so if you don't feel like using Mocha Pro, you don't have to. So here's some footage that was shot, and this is from FXPHD. This is supplied to me as footage from them, so we're free to use it as we see fit. So I'm going to find 2 loop points, and I'm going to do 2 full cycles of this bird flapping its wings. So let's trim it right there and right. Wait, 1. It starts here. 1, 2. All right. I guess I'll call this 0, 1, 2. Right. Now I'm going to use Mocha for this. You could use Mocha AE. I just have Mocha Pro installed on here, and I'm going to use Mocha Import for this. And this is from ascripts.com. I believe it's $35, but you can get a free trial of this as well. And the reason I like using this is because it simplifies the workflow of getting back and forth from Mocha. Generally, what you would do if you don't have Mocha Import is right-click on this, say Reveal in Project, and then right-click on it again and say Reveal in Finder, so you know where the clip is. And then go into Mocha and then import that manually. This basically simplifies the whole thing. So I'm going to select this. I've trimmed it up to the areas that I'd like. I'm going to click on Track in Mocha. And I've done this before, so I'm going to tell it to create a new project for those selected frames. I'll just do this quickly. Don't save the old project. So here's my bird. It's neatly trimmed up for me in Mocha. And what I'm going to do is just drag some splines around this. Now it's not going to be perfect. I mean, this object is changing quite a bit from frame to frame, and as good as Mocha is, it's still not going to get this perfectly. But I'm going to use a high number of minimum pixels used to match from frame to frame. I certainly don't need perspective, and let's just track away and see what we get. So in fact, I can go up here and click on Stabilize to view what this stabilized version looks like. As the wings flap, it does sort of contort the image this way and that is going to sort of screw up the scale of the image a little bit. But we'll work with it. So let's move this forward. There we go. So we're going to do two things here. We're going to use the transform data. So let me save that as bird underscore t. I'm just overwriting my old data because I've done this before. Yes, overwrite it. And I'm also going to export the corner pinning data and click save and save that as bird cp. Yes, do all. So back in After Effects, again, you can manually apply these. So I can go in, apply either corner pin, or you can use Red Giant Warp corner pin, which is also great. Reason that's I like that one because it supports things like motion blur and from pinning sources and all that. But we don't have to use it for this. In fact, I don't think we'll necessarily need that for what we're doing here. But what we want to do is stabilize. So I've selected stabilize, and it's telling me what I need to load in to apply that. So I need to load in corner pinning data, which I had saved, and transform data. So let's load these in by clicking load. Go to desktop, and what was I doing? I was doing corner pin. Load corner pin. Yep, that's what and then I'm also going to load transform data. Yes, and apply. I want to eliminate all of my movement completely. So let's click on that, and we have a fairly stabilized bird. Let's trim this down to 500 by 500 or so. It does all of the stabilizing with position, I'm sorry, with anchor point. So I actually can move the position around quite freely without adding additional keyframes. Let's set a range here, just B and N, and then right click, trim comp to there. So we've got our trimmed bird here. I'm just going to kill all the scale keyframes because I don't think it does us any good, and push that back up to 100. It shifts just a little bit. So what I did when I did this is I did some manual location here, or relocation and animating. So I set a couple guides here that intersect right on the bird's eye, and set some keyframes so that at the beginning keyframe and the end keyframe that the eye is at the same point, because that's really ultimately what we're concerned with is that loop point. Now we're going to speed this up, so this doesn't have to be 100% perfect. Okay, and we need to key this out. And actually, what you're seeing quite a bit of noise in here. Now you can deal with that. Just to show you what we can do here is use denoiser to, well, denoise the footage if you want. You don't have to. But it might make your keying easier. I'm just going to leave it as is and deal with it without denoiser. So we just want to key this out. You can key it with your favorite keyer. I'm going to use Primat just because I like the workflow of Primat. But you know what? If we're doing a university bundle, I don't think we included Primat. Oops. So I'll do it both ways. So let's select and clean the background. So we have a nice clean background area, and then click on clean foreground. Scribble those in so we have clean background and foreground. I'm going to go into alpha controls here and look at the gamma of my alpha channel. And let's squeeze this together. Now, if you don't have Primat, you can certainly just use something like Keylight. Let's go in keying, Keylight. Hopefully this does a better job. Yeah, you can see the keyer struggling with that noise. But in fact, this really might save our key if we add denoiser. Here, keying, Keylight. Let's key out that blue. There we go. It's a little bit fuzzy. I think this noise reduction is actually pretty extreme for our clip here. So that basically how we get our bird prepped. Like I said, I will. Oops, what am I doing here? Clicking in the wrong spot. I'll include the pre-rendered bird. In fact, it looks like I need to clean up the alpha channel just a little bit. Let's see if I can find that. Let's go into my error. This is my final version here. Here's my bird keyed, and there's my footage. Let me drop this in here. So I basically just rendered it, pre-rendered it, so that I've got my bird there. In fact, let me fix this right now. Take a look at my alpha channel. Option 4. Yeah, got a little gunk down there in the corner. So let's go into color correction, levels, alpha, and get rid of that. Sound effects are necessary. The source material is bird keyed 400 by 400. So let's trim this comp to 400 by 400. There we go. Now we got a nice little source particle to use in our comp. Bird particle. Watch out for bird particles. Okay, so this is our lesson version. There's our bird particle. And I want these birds to sort of flock in through the scene and create that logo, or at least overlap with the logo. So let's get the logo in place. I spent all of about 5 minutes designing this logo. Oh wait, we're not doing logo, I'm sorry. We're doing a type treatment. So let's load in our type right here. Let me show you what I'm using. And of course it's black on black, so let me just temporarily change this background color to white. There we go. Or actually, let's do neutral gray so we don't lose everything in here. All right. There we go. So, this isn't a course on typography, so I'm not going to spend all day going through and nitpicking our type. But what I did do is I created a simple treatment that just has whatever we're promoting, if it's a show title or when this bumper is what we're talking about, what it is and when it is, which is pretty common. What I used for this is a sort of a demo typeface called Code by Font Fabric. So if you go to Font Fabric, or just search for Code Typeface or Code Free, or Code Font, I should say. Technically, this is a typeface. It's one of those things that bugs me. But anyway, it's a typeface, but you can call it a font. It ships with 2 fonts, light and bold. And there's a more varied one that you can buy. I think it's not too expensive, $35 or something like that if you want to buy the whole set. But there's a light version and a bold version, which I thought worked well for this. So this one up here is light, and the bottom down here is bold. And this is sort of the type treatment that we'll follow that we'll be revealing. So we want to reveal this type. That's my sort of type guide that I'll be using throughout these IDs. So I want to have my birds flock in through this. This will be the last thing that we'll do in this lesson, and then we'll finish this up next week, creating the mat and filling in the additional elements. So let's create our motion path. So a motion path is a light. Well, basically, it's a light, or it's a path of particles that particles follow, and they emit along that path. Now, the difference between just moving, animating your emitter in space and a motion path is that the particles are emitted along the path and move exactly along the path and will not stray from that path. Whereas a motion path is, or just moving your emitter is, well, you're just moving your emitter. The particles are being born at that point along the emitter. So anyway, let's demonstrate this so it actually makes more sense. I'm going to create a light, and I need to call this motion path 1 to be used with my motion path. And notice as soon as I created that light, it's actually affecting my 3D object in there. Which my mountain is set to accept lights. I can just turn that off if I want, or actually I like how it kind of darkens it. If you don't want a motion path to affect the rest of your scene, what you can do is simply click on the adjustment layer, switch for it, and then move it behind all of your objects, or move it to the bottom of the stack. Nice little handy tip. So let's animate the path of this first. So let's start it back here, sort of behind the camera a little bit. In fact, let's look at the top view, and the top view so I can see where my camera is. So I'll kind of move it from there. So a keyframe, and then we'll have it move here, right where that type is. So if I select that type layer, you can see where that is. And then move this over that way. And maybe we'll add some additional movement in here. Let's see. Okay, now as great as it is to look at the top view to estimate where you want things to go, it looks great there. And as soon as I go here, it's actually nowhere to be seen because it's way up here. So let me just select all these points just by clicking on the position property, and I can drag all of these down to actually get that in the right plane. There we go. This first one, this first keyframe, I move this up a little bit back. Basically, I want these birds to sort of swoop by the camera, but it doesn't have to be that close because it's going to make them appear to move extremely fast as they zoom by the camera. We don't really need that. I just need a little bit of motion kind of passes by the camera. To add some additional curvature to this path so that they kind of swoop in and just kind of move around this. We're going to make a separate layer of birds that actually act as the mat. So we'll have these birds that kind of come in and flow along this text, and then we'll have a separate pre-composed layer that is just a bird mat that flows along the text and reveals it. So I've got my bird particles in here. I've got my motion path. So let's set the birds loose. Let's make our birds particle. Bird particles. There we go. Effect, track code, particular. And what I want to do is go to physics, error, motion path 1. That's where that name comes from. Guess what I'd have to call it if I wanted to use another one? Motion path 2. Name the light motion path 2. You can only use one motion path per layer of particular. Now the other trick here, I've actually done a number of quick tips on this. This is always something that I cover because it used to be very confusing for me, and I guess it still really is technically confusing. But think of this. We have a 3D world of After Effects, and we have particular that is a 3D world. Generally, the 3D worlds match up. That's how particular works. It always matches the 3D world of particular to the 3D world of After Effects. But they are two completely separate things. They're just mimicking each other, or particular is mimicking the world of After Effects. In fact, we can transform that world to shift things around so that this world of particular is actually offset from the world of After Effects. But one time that world needs to be manually aligned is with this motion path, because we have our motion path position, which it's following, but the emitter position is still independent. Notice this isn't grayed out, and our emitter types haven't changed. We can still emit points or box or sphere shapes along that motion path. So I need to align this position to this position, the motion path position. And the easy way is just to copy and paste the values from the very first keyframe. So X, Y, and Z. I'll post in the notes here or a link or something like that of a quick tip that I did that went through how to do this with expressions, because if you go back and you change this motion path, you change the very first frame, you adjust it, your worlds will be out of alignment and you'll have to go back and copy those frames over again. So that's why it's a good idea to use an expression sometimes, because it actually eliminates some of that sort of doing the copy and paste method over and over. So now we see that we have our particles moving along this path, which is nice. They have a velocity that even though they're flowing along this path, it's going to have an added velocity that flows along that path that will stray them tangentially to that path, or from that path, I guess I should say. So I'm going to set this to a very low value, and we also are using a point, which I don't want. So we're emitting a single point along this motion path. I'm going to use a box. That way I can expand this out in X, Y, and Z. And now we're flowing these soon-to-be birds along this motion path. Maybe we want a little bit of velocity random. That's really about it. Now let's get into the particle type itself. So let's go into the particle section. Actually, we should crank up the lifespan because we don't want any birds just disappearing in midair. And we'll come back to the size. Let's get the particle type itself set. So again, we want a sprite because we have a flat image. We don't have a 3D bird. We just have a two-dimensional bird that we want flat to the camera. I'm going to use colorize, so we don't have any of the color from the original. We'll just colorize it with this. So we'll make them, I don't know, kind of dark grayish blue or something. I don't know. We'll come back to that. But let's get to the texture, and my bird particle is in here, right? Yep. And I mentioned we were going to speed this up. Actually, let's just keep this at around 10 seconds. That seems pretty good. And if I need to speed this up, I can come back in and speed it up. So let's go into our particle birds, and set this layer to bird particle. Crank up the size. I know it looks very unimpressive right now, but what we can do is go into rotation and orient to the motion of the path. So as they move, the particles will orient along that path. Now we certainly need some randomness in here, so let's go in and, because that is a looping clip, I can say randomly loop. There we go. They do look a little dark. This color here might not be ideal. I mean, we can go kind of like dark like that, or we can kind of lighten them up. We can also add motion blur, so I'm going to turn on motion blur for the comp and turn it on for the birds. Actually, another thing we might want to do is go into our keyframes here and select row of across time, so that this keyframe right here is evenly spaced, so the motion is evenly spaced. And the birds will flock across that front. And then we'll add in a separate pass of birds to mat this out. But I think we've covered quite a bit of stuff already. So we'll finish this up in the next lesson, creating the matte wipe, and just doing a little bit of color correction and finishing this ID up. So thanks for joining me at week 2 AFX 217. Any questions, hit me on the forums, and we'll see you next week, week 3.